Thank you.
My name is Gudmestad. I'm working as Professor of Marine Technology at different universities in Norway. I write this paper as a part of my work at Western Norway University of Applied Sciences. I'm concerned with the selection of safety levels for marine structures. Okay? Let's first state the background. The background is that the safety level is determined by a selection of action, and for certain actions or loads, we define two limit states. It's the ultimate limit state, where we shall have no damage to any structure. A reference 100-year wave loading. And we have the abnormal limit state, where we shall have no collapse of the structure. Reference a very long period of 10,000-year criteria or whatever is listed. And the ULS and ALS annual exceedance values, they are based on the consequences of failures and are very important decisions to select these. We also have decision to select the safety factors or multiplication of the loads from the ULS. The probability of exceedance selected for marine structures and application factors. This is the scope for this paper, and this is the safety level selected for structures. When it comes to, for example, to nuclear power plants, we have very, very high safety level. Okay? When it comes to the barn, where there is no animals, we can accept a very low safety level, for example. Okay? The safety level first in the oil and gas industry, that will be very well established because of the huge pollution effects there is with the oil and gas industry. Also, if there's an explosion on an oil and gas platform, it's very dangerous, and we can lose several tens of up to 100 persons, and this has happened. So the ULS value is the annual probability of exceedance of 1 out of 100, the 100-year value. S value is 1 out of 10,000 in the oil and gas industry. That's 10 to -4 annual exceedance probability. If we have an unmanned structure, we could design for lower safety level in case the environmental pollution is limited. Here I have the example of a very large wave on a very large offshore structures in the North Sea. Of course, the waves can be even larger than this. This is what we're talking about when we select the annual probability of exceedance. This might not be the 100-year wave, but somewhere in lower than that, because the waves can be larger than this. Then it's the wind industry. That's what I'm interested in for a moment. The safety level in the wind industry is lower than the safety level in the oil and gas industry. That sort of makes sense. But the ULS value is annual probability of 1 over 50 years. And this is a 50-year exceedance. ALS value, the collapse value, is varying. Sometimes it's not even considered. The set of design requirements are given in the international standard, International Electrotechnical Commission standard, and they should ensure that the wind turbines are appropriately engineered against the damage. Okay, but however, we should notice a couple of things. One concern is that the level of wave action is very uncertain, and that happens when there are breaking waves over shoals. When we have the wind turbines mounted on top of a shoal or underwater hill. Okay? Then we could have a systematic underestimation of the wave conditions, and because of this uncertainty, we could have a progressive collapse. Say if there was 100 wind turbines in a wind farm, we could have several tens of wind turbines collapsing. That's one thing. The second thing is that all wind turbines, there must be lubrication. There's mechanical equipment with in the nacelle, and we need also lubrication and also the oil for cooling the energy in the transformer. On all the wind turbines are local transformers. So there is up to 1,400 liters of oil in a wind turbine, and loss will represent an environmental damage, not as huge a process for oil and gas, but also could be considerable. When it comes to the wind and the waves of our shoal, I refer to Dogger Bank. The Dogger Bank is the shallowest part in the North Sea. The shallow is 20 meters, the 19 meters. Typically, 40-meter contour is over a big part of the southern North Sea. Here from the north, we have a gradually sloping bottom, and on the sloping bottom, the waves can break. Then when the waves are rolling past the structure, the waves are more or less controlled. We know the load, but when the waves are breaking on the structure, we have a much higher load, and there's a lot of uncertainty on which periods and wave heights the waves will be breaking. One of my students, Mr. Choi, he looked at this map, and here is also the outline of Doggerbank, and on the red spots, a possibility for having wave breaking when the waves are coming up from the north. You can see there is a pretty gentle slope from the north. So because of the uncertainty in the estimation of the wave load, I think we should consider the safety level selected. Here is one way to solve this. Has been for Thornton Bank offshore Belgium. They put up the structures of concrete, and these structures I have as to the left. These structures have very much larger foundations than the single piles that are used for most of the southern North Sea. They will be more stable in the case of breaking waves. Of course, they are larger in diameter, but they can take a lot of moment from the waves. When we go to the floating wind turbines, we have the floating wind turbines, and between the wind turbines there are cables, okay? And the blue, there are anchor lines, and there is offshore service station, which is basically transforming the alternating current, the direct current, to send it to the shore, to also another substation and into the grid. So the offshore substation, it complicates the wind turbine in the wind farm very much. So the wind farms require these transformer stations. They have a lot of transformation oil, up to 19,000 liters of transformer oil, and even more. And the Norske Veritas in there, and then DNB ST0145. They request that if there's more than 15,000 liters, 15 cubic meter of transformer oil, then there's a spill. That's a massive effect. So we should avoid that any damage to the or at least the collapse of the wind turbines, or not the wind turbines, but the offshore transformer station is avoided if there is a lot of oil on the transformer stations. The transformer station is also very expensive compared to each wind turbine. And in case of a transformer station is out of use, the wind farm during the period of repair of the substation will not produce, and it could be several years to build a new substation. So we lose a lot of money. They don't produce anything, and we also have to come up with a new transformer station or a substation. Here is an example of a very solid substation being set on the seafloor in the shallow part of North Sea. You see here that it also has a possibility for people to stay over, because there's a lot of repair work, maintenance work on this transformer, and it's also that from this substation we also send out boats to service the different wind turbines shown on this picture. So my concern is that we have to look into when particularly now that we have floating service systems, the safety level, is that sufficient as it was in the southern North Sea, or do we have to increase the safety level? My suggestion is potentially we have to increase the safety level. As I say, if you cannot afford safety, try the cost of an accident. Try the cost of 19 cubic meter of transformer oil into the area where there's a lot of fishing. Next field of business I will look at is aquaculture industry. Lower safety levels are specified by international standards, 50-year return period, not so much on collapse criteria. But we should notice that the fish farm, marine fish farm, there's a lot of fish in the fish farm. There's several thousand. And if they are able to leave the fish farm and mix with the wild fish, and we destroy the genes. Okay, so we have an environmental damage. I consider this. I call it a very serious environmental crime, even if we have the escape from a fish farm. And this is not unusual. There are a lot of escapes from fish farms. So the more the fish population needs to be fed every day. It's not like the wind turbine. If wind turbine is standing still, it's okay. But the fish farm, we have to feed the fish every day, or we will have another environmental crime that there are thousands and thousands of dead fish. So there must be people available to ensure the operation of the fish farm. And if the fish farm is out in the open in large waves, as there is a tendency to in Norway these days, we should absolutely ensure that there's no collapse of the fish farm. So the protection of the selection safety level is crucial. Okay, and I refer to an ISO standard here as well. This is the map I refer to. This is up in the northern part of Norway. Here we have all the islands. Welcome there for tourists. Okay, can't go to Tromsø, too expensive. But you see here out in the open sea. Here is to the west of this location is open Norwegian Sea. The wave conditions here are up to 25 meters high waves if you look at the maximum waves. The significant waves are typically 10 meters. We like to anchor up a fish farm out here. Okay, this fish farm, the fish shall be safe. The fish shall be taken care of. The people working there shall be taken care of. This is a dangerous situation. You have also in this part of the northern seas, you have also icing, sea spray icing. And with sufficient sea spray icing on the net, and the net can sink under the water level. Of course, the net and the ice would not sink below the water level, but net can sink under, and we can have escape of fish. Look at this person here, has no safety nets, no safety. It's a very dangerous situation. So what I'm talking about is the safety level for marine structures. I refer to oil and gas structures, okay? And I look into what the wind industry and agriculture business are requesting. I'm a bit aware that maybe there is an underestimation of the safety level for the new types of wind farms, okay, in deep water, and the new types of agriculture nets out in the open sea. And I call for awareness for safety of people, of the environmental pollution, also from wind farms, surprise, surprise, and the potential loss of assets. And I suggest that the safety level should be increased, well, only after a thorough review internationally. And awareness of uncertainties. Uncertainties give also the multiplication, the safety factors, which is a part of the safety level. And I also would stress that these new industries, the oil and gas, the wind industry out in the open ocean, and the Atlantic, the northern North Sea, the Norwegian Sea, it's important that must set also sustainable goals should be in place for these industries. That's my presentation. I would like to prepare a paper for this if you accept. Thank you very much.
Yes, thank you.